Hi everyone, and welcome to Psyched with Setmire. Today what we're going to do is look at color after images. So we'll describe a little bit what are color after images, why do they occur, and then I have a couple of examples that you can see here. We'll look at a flag, we'll look at a bird, a fish, kind of bombarding your eyes with a couple of different after images today. So what is an after image? Very basically, it's just an image that continues to appear in your vision after exposure to original image has ceased. So you stare at something and then you either see that same thing or maybe even the opposite of it once you're done. So it can take two main forms. An after image can be positive in the sense that it retains the colors of the original stimulus, or it can be negative where you see kind of the reverse, and that's really what we'll be looking at in this little presentation today. So with a positive after image, say you stare at something for a long period of time, it's almost like it burns itself into your retina and you can still see it when you close your eyes, even ever so slightly. Versus a negative after image, you get a kind of fun effect that can happen when you see the reverse colors of whatever it is that you've been staring at. So let's talk a little bit about why color after images happen. And a color after image would be a great example of a negative after image. So why do they occur? Color after images, or again negative after images, are caused by fatigue cells in the retina responding to light. And they can really be explained by the opponent process theory of color vision. So the opponent process theory is one of two theories trying to explain how and why we see color, but it looks at the idea that color perception is controlled by the activity of three opponent systems, or another way of thinking about that are three independent kind of receptor types which have opposing pairs. We have a pair of white and black, a pair of blue and yellow, and a pair of red and green. And the colors in each pair oppose each other, hence the name. Red and green receptors can't send messages about both colors at the same time. So you get a kind of interesting effect if you stare at red for a very long time, or blue for a very long time, or white, or so on. So if you were to stare at the color red for about 30 seconds, or maybe a little bit more, the cells in your retina that respond to red are going to get fatigued, and they're going to fire less. So when you then switch over to kind of a blank white surface, your eyes are going to subtract the red and you'll see its complementary color that is green. All right, so we're getting these ideas of these opposing pairs, very much evidence of this opponent process theory. So let's look at a couple of color after images just for fun. This is a very, very common one. So as I'm talking, stare at the white dot in the middle of the flag. Keep staring at it. I'll tell you when to stop. But here's a very common example. Obviously, it doesn't quite look like the flag we're used to seeing, but it will. So keep staring at the white dot. Just a little bit longer. And here in a second, I'm going to switch to a blank white screen. And if you've been staring at that white dot, you should get kind of a fun color after image. All right, so here we go. So hopefully you saw a flag, right? Red, white, and blue, and you might even still be seeing it a little bit as you're kind of looking around. But again, that's a color after image because you were staring at the green and the black and the yellow for so long, those cells became fatigued and you see red, white, and blue on this white page. Two more for you. If you stare at the eye of the parrot for about 30 seconds, right, so keep staring at that little eye, and I'm sorry if you still see a flag, right, feeling patriotic, but keep staring at that white eye of the parrot. And in a little bit here, what I'm going to do is I'm going to pop up a cage. And what I want you to do is look over at the cage on the left and see if you can put the parrot in the cage, right? Very common after images, you might see kind of a shadow of the bird appear in the cage, or it might kind of move across the page a little bit. But here we go, keep staring, a few more seconds. And here's the cage. Look at the cage on the left. Okay? So hopefully you saw the bird in the cage, right? Maybe, maybe not. Some people respond to different colors better than others. But you should have seen kind of an image of the bird, and sometimes it kind of travels down or moves a little bit. One more for you, and hopefully you're still not seeing the flag. Right now you have a flag and a bird. Let's add one more thing for you here. If you struggled with the bird, maybe you'll have better luck with the fish. I want you to stare at the yellow stripes on the fish for about 30 seconds. And same kind of idea here. As soon as our time is up, I'm going to flash up a kind of fishbowl on the right. And I'll have you look at the fishbowl and see if the fish moves into the bowl or you see any kind of color after image. So keep staring at the yellow stripes. Alright, here we go. I'm going to put up the fishbowl. So go and look over at the right. See if you see an after image of the fish. Alright, so hopefully one of these for you was something that you did see the color after image with. I think the flag is definitely the easiest example. But all of these, again, are happening because of this opponent process theory of color vision, where these opposing pairs are getting fatigued and firing, allowing you to see the opposite color. So hopefully one of these was entertaining, and I'm sorry to bombard your eyes with a bunch of stimuli today. But thanks for joining me, and I hope to see you in the future.